Okay, thanks for your reply. So I'm going to start. And today we are going to talk about Java's type system. And we will have 13 items in below areas. Sorry, my name is called Cheng, and I'm a Java developer from EPAM, China. And it's still mandatory to wear masks, so I have to speak in this way. And today's talk will last for about 30 to 40 minutes, and after that we will have 10 minutes for question and answers. And before we get started, I want you to know something that these items may be simple, and some of you may already know. We will generally spend less time in simpler ones and more time in more complex ones. So you've got the idea. And some examples can be contrived. And we will have some bonus questions and tasks for some items and at the end of them. So let's get started. So can you tell the difference between integer type and integer class? Have you ever used the first one? It turns out the first one is primitive type and the second one is object type. And remember their difference. Here, what I want you to know is that primitives in Java also have their own types. And please look at this example. We are ready to compile. Here we have a very simple class user. It has a field ID, a constructor, and a getter, and we are going to create one. So we are ready to compile. Just think for seconds. No. Here the problem is because this autoboxing here. If we're going to let it compile, we have to give it a long, primitive long. Okay, let's move on. And will this statement compile? And if it does not, what's the problem? It turns out it does not compile because this 65,000 exceeds the upper limit of a primitive short, which is a side number. And what about this statement? Well, I give you several seconds to consider if it compiles or not. It compiles. It's a valid statement. And what about this one? Can we assign an int array to an object array? Will it compile? No, we cannot do this conversion. So at this point, can we draw some kind of conclusion or summary that what is autoboxing essentially? So what it is essentially? Autoboxing is implicit type conversion. It converts primitive types to object types. And let's return to this user class. Can you spot any problem of it? Is it ill designed? We do have a problem here. We could possibly have a non-pointer exception here. Primitive types does not accept none. So there is contract change. This is very important. Everything in Java has a type, including primitives. Autoboxing and unboxing is type conversion with contract change. Let's move on. Suppose we are going to design a starship. So we have a method shoot, and we can burst the shoot. Now we are going to extend it. We are making a super starship. So we are going to override the shoot method. Now, when we call this burst shoot on this superstar ship, what will happen? So simple bool or boom, which one? Actually, this is pretty much intuitive and by design. It's this one. If you think it in simply in object-oriented programming way, but sometimes it could have some problem. Like this example taken from the book Effective Java. Here we are adding some functionality to this counter set by extending hash set. So we are going to count how many elements are added to this set. And we have overridden this add method and add all method. And every time an element is added, we increase the count. Very simple, right? And looks good. Now, we are going to insert some values, some elements into it. And at this point, if we are going to retrieve the count from it, one number will be returned. Is it 3? No, actually it's 6. So what's the problem? The problem here is because this add all method internally depends on add. So when every element is added, we will have a duplicated count. Be cautious when overriding an already implemented method. Let's move on. Now, can you tell what's the type of these 3 arrays? So array 1, 2, 3. I think this is pretty simple. Integer array, and object array. This is because the assignment is valid is because by default Java arrays are covariant. So the type integer array is a subtype of object array. And will this statement compile? Can we assign a string to our array 2? Well, obviously compiles, but we will have a runtime exception because the type of array 2 is integer array and we cannot assign a string to it. And what about this statement? Will it compile? So can we retrieve class or type from a primitive array? Will it compile? Is it a valid statement? Yes, it is. And what about this one? Can we create an array in this way? Yes, it compiles, but never write in this way. It kind of doesn't make sense. So what is the type of A? Write it in this way so that we are clear that the type of A is an int array. And what about this statement? Will it compile? Can we create a generic array in this way? No. So if there's some way we can create an array with specific type and runtime, actually we do. Java's Reflect API has provided us this way. We can create an array with specific type. And here what I want to emphasize is the runtime type of arrays. Arrays have their own types, and beware of their runtime types. Let's move on. We have a bonus question here for this topic. And here we have a very common implementation of bag. So we are using an object array to store these elements here. But the problem here is that every time when we are going to retrieve element from it, we have to do typecasting because the type of this array is object array. So can you re-implement this back without typecasting here? Well, this bonus question is left for you guys to do it later, so we will not spend extra time here. But and this material will probably be distributed out, so you can have a look at it later as well. So let's move on. Now let's consider this method. It's very simple. It simply returns the arguments and an array. And now we are going to call this method in another method. We combine these two generic type to an array. And now we are trying to combine two numbers into a number array. So what is the output? What is the possible output? Think about it. It turns out there's no output but a runtime exception. The indicator is object array cannot be cast to number array. So what's the problem here? It looks harmless, but the reason is because the type T falls back to object at runtime when the first method is called. So no matter what the type of T is, the type of the returned array is object array, which is not a subtype of number array. Don't use var arguments with generic types. Okay, let's move on. Here we are going to create a class with nested parameter types. So can we get a literal in this way? Is this statement valid? No, we cannot do it in this way. If we are going to get a class with nested type parameter, we have to do double casting. We cast it to object first. And a question here is that is our type equal to the type get from an optional empty? So is it true here? Are they equal to each other? Yes, they are equal to each other. And this is also an example of how generics works in Java at compile time and runtime. Use double casting to get a nested type parameter literal. Okay, let's move on. Well, in this example, we want to make our container comparable. So we extend this comparable interface. And if we implement our container can compare to another container. But what about this one? We can give the type parameter simply a type string, and this may not be something we want. So can we put a limitation here that a container only compares to another container? Can we do something on this type parameter here? A technique is called if-bounded type parameter. Sometimes it's also called recursive type parameter, where this parameter type E is a subtype of this container itself. And in this way, this type T, this type parameter type E is effectively bounded to this container. As you can see, now we cannot give it string, a type of string, because string is not a subtype of container, right? But what we want still works. Another example of this if-bounded type parameter usage is we can grant the interface the ability to be aware of its subtype. So here in our implementation, please notice the return type of this interface method rename is the subtype itself. So when we are processing an instance as its interface type, we still know the subtype. Use if-bounded type parameters as a constraint or to provide subtype information. Sometimes when you are, especially when you are designing API or library, you want to put this limit on your API. And it can be handy. Item 7. Suppose we have a method which is only efficient if we give it a random access list. So we limit the argument as array list, but it's not very flexible because we can also implement our random access list instead of this using this array list as well, right? So can we make it more flexible? Obvious way is that we can loosen the type limitation of this argument to its interface and check if this list is a random access list at runtime, then do our job. But the check is moved from compile time to runtime. So can we make it better? A technique is called intersection types. Please notice here this ampersand, which literally means add. So this type parameter list, a capital list, is a subtype of list and at the same time a subtype of this random access. So in this way, we can give it a random access like array list or any other random access list you designed, but not this one, but not this linked list. Use intersection types to add constraints while retaining flexibility. Here we have a bonus question related to items 6 and 7. So in order to achieve below examples, in order to make them valid, can we design a supertype, say an interface, where its subtype are constrained to enums? Well, you can do this practice later. So let's move on as well. Sometimes we want to get the parameter type, like in this example. But the question is it possible to capture it at runtime and automatically? Actually, it is possible. Google Guava has provided this type token class, this API, which is essentially an implementation of Java's reflection API. And in this way, we have created an abstract class and we extend it. So in our car factory, the type parameter can be captured at runtime. The supertypes information is part of the car factory's type information, so we can retrieve it via Java's reflection API. Type parameter can be captured by subtypes at runtime. Let's move on. Now, for this example, we are going to compile. We are using wildcard parameter, type parameter here. And this method is very simple. We just get an element from it and restore it back to the list. And we are ready to compile. No, it will not compile. The problem here is because of this wildcard type parameter. The compiler will treat them differently. The captured wildcards are different types seen by this compiler. One for this method and the other for the method get. In order to make it work, we need to use explicit type parameter so that this compiler knows the type are the same type in this method. They are the same type T. Suppose this process method is an API and already published, and you cannot change it. I think this technique can be useful sometimes. Use generic types to reconstitute type information. So let's move on. Here in this example, we want to process a list of numbers. And we want to process a list of integer, a list of doubles, and will it compile? Will these statements compile? Can we pass list of integers into this process number method? No. This is because Java's collection by default is invariant, which means this list of integer is not a subtype of list number. In order to make it work, we need to specify or use this wildcard type parameter, or specifically this upper bounded wildcard type parameter. In this way, we are making this list covariant, which means list of integers and list of doubles are both subtype of this list. So now we can pass them in and make it more flexible. Okay, so now will this compile? Can we insert an integer into this list? No. We have increased the flexibility and the cost of inserting elements into it. Now let's have a look at another example. Here we are trying to fill this list of Fibonacci numbers. It's straightforward. We create a list of integer and we call it. No problem. But what about this one? Well, we think that it should work, right? If we are creating some numbers, we should be able to insert numbers, what is integer or any other numbers into this list of numbers, but actually it does not compile. So how can we loosen this type limitation here so that we can pass a list of number in? In order to make it work, this time we use a lower bounded wildcard type parameter. And in this way, we are making this list contravariant. So list of integer and the list of numbers are both subtype of this list, and we can pass them in. Use bounded wildcard type parameters to maximize type flexibility. Okay, one bonus task for this topic is for you is to recap this phrase, producer extends and consumer super. This phrase is tightly related to variances. So let's move on. The purpose of creating a tuple is sometimes because if we are going to return multiple values in a method, Java doesn't support it, so we need to create a tuple and put multiple values in, right? Like in this example, here we have 2 intermediate results, and we want to return it as a 1, so we create this tuple 2. But my question here is this tuple 2 really necessary? Actually, Java's type inference system is powerful enough for us to handle this problem. We can simply create a new object and return it. With this newly created object, we define 2 fields, letter and number, and its type will be perfectly inferred in the next call, as you can see in this lambda expression in the for each. We can call the letter field and the number field of this newly created object. Sometimes it can be handy. Item 11, utilize type inference in cascading method call. Okay, now we have another example. This method throws an exception. Notice this is a checked exception. And can we use it in this way? Can we use this method reference directly? Obviously not. If we are going to make it work, we have to try catch it and throw a runtime exception instead. It's kind of verbose, and we feel it has lost some of the benefits provided by this method reference, right? But how can we make it better? First, let's have a look at the function interface consumer signature. It has a method accept. There's no exception throw. There's no checked exception signature here. But for our method that throws an exception, it conforms to this function interface, which defines a checked exception, which throws exception. So think about it. Can we bridge them? Can we bridge these two function interface so that we can still use method reference? And here in this unchecked method, we convert this throwing consumer back to a normal consumer. We extract this try catch logic to this method so that we can use it in this way, as we can use method reference again. And here I want to take this step a little bit further. Is it possible to remove this runtime exception wrapper? Is it possible? So is it possible to use the original checked exception instead of a runtime exception? Is it possible? It turns out it's possible. And we can kind of fool this compiler. Here, we are doing typecasting here. We are casting this type of exception to a generic type, which is subtype of checked exception. And in this way, the compiler will treat it as runtime exception. It will not treat it as checked exception. So we have achieved both benefits, one for method reference, and now we have simpler stack trees. Use generic type casting to work around checked exceptions. Now we have reached the last item, and before going to the point, I want to talk about something basic. In Java, we implement an interface to implement its behavior. Like here, we have this cat, which implements this predator interface. also this behavior of eat a prey. So we have fish as this prey. But what if we have another predator, which is a lion? So, and the lion don't eat fish, right? Notice that the relationship between this lion and the fish is introduced unintentionally. We have to make the check and runtime, and this is not what we want. So can we avoid this problem? In ad hoc polymorphism, or specifically here, overloading, given these domain objects, we can implement specific relationship of these domain objects using overloading. And overloading provides us polymorphism as well. But the problem is that overloading itself has an issue. So you can see it doesn't work in this way. Do we have other ways? Now, typeclass. This concept was introduced first in the 1989 paper, How to Make Ad Hoc Polymorphism Less Ad Hoc. In the programming language Haskell, typeclass is implemented. And in some other languages like Scala and Rust, typeclass, the functionality provides way to implement it. But in Java, we don't have typeclass. Still here, we can adopt some of its idiom into our programming. So I'm going to talk about it in Java. Look at this interface JSONable. It simply converts an object to a JSON string. And we have another utility method which does the actual conversion. And here, please notice we supply this interface JSONable as an evidence. And remember this name, why we call it an evidence. Now, to make this class A JSONable, we can either implement this interface as a class or provide an implementation in a method. They are both implementations. And moreover, they are both evidence that this class A is JSONable. So let me repeat that. These implementations, they are evidences that this class A is JSONable. So that if we can supply this evidence, we know that a certain type is JSONable. And here you notice that these implementations, they are separated apart from this class A. And this class A is not aware of this JSONable implementation. So we can implement for a specific class in an ad hoc way. Here we call this interface JSONable a type class. Okay, in some languages like Scala, this evidence can be provided by the compiler implicitly and compile time. We don't have this functionality in Java, but still we can make it better. With the help of a heterogeneous container, like in this example. In this example, we use this heterogeneous container hash map to store implementations or evidences. And we retrieve this evidence or implementations at runtime by the type of the input. We have achieved the same result in a similar way. The only problem is that the check is at runtime, but we still have the benefit of the implementation and the domain object separation. In this way, we can design a better loose-coupled components. Apply typeclass idiom with the help of a heterogeneous container to separate implementation apart from domain objects. Another bonus task for you. This is a type converter interface. It's similar but a bit different. And you try to implement this interface. It's actually implemented by Spring Framework. And I suggest you to have a look at how Spring Framework implements it after you have done the work. Okay, we have finished all of these 13 items, and I hope they be able to help you be better Java developers. And at last, I want to give you a single word: keep it simple. Now, I see already you have sent some questions here, and I'm going to try to answer them. Oh, I'm sorry, I didn't see some suggestions on the volume. So please, we still have more than 10 minutes to answer questions. So please ask some. If you have some questions, you can type on this page, and I can see them. And don't forget to vote for a talk. We will have prize for the best question. So here's a question talking about Kotlin's type system. Do you think Kotlin's type system is better than Java's, especially when it comes to type inference and lack of primitive types? Talking about if it's better, well, I think that it depends on how to define what is good or what is bad. For example, the type inference in Java's future version, we have local variable type inference, and I think they made this decision not very easy, because with more power comes more responsibility. This type inference or some powerful functionalities, they are provided by the compiler, so it requires programmers or designers of compiler to be very competent, and also it kind of give this compiler more computation tasks. So if sometimes if we are going to make less coding, like use this compiler to infer everything we want, literally we are giving this work to this compiler. And in my experience, for example, in Scala, this type inference can, if this class is so big, this type inference can be slow, which can be failed. Kotlin is designed, I think the designer, they already put the concerns of Java in their mind when they are designing Kotlin. So generally speaking, Kotlin will be more advanced entities than Java 8 or so. But I believe in the future, Java also will kind of catch up. And in my opinion, Java is a practical language. It's more practical than Scala. Scala has more features, more functionalities. It has a academic background rather than Java. But now today we can see that for most projects, especially for real projects, we are still using Java. Okay, the next question is, will you explain bolus questions? I think I can, but you need to give me which one to explain. Any thoughts on best practices based on scenarios? So, can you give me some details? What kind of production experience you had related to the topic? Interesting issues, optimizations, or something? Let me think for a while. Some of the example, or I discovered them or studied them during my design in a library. It's definitely for production, and at that time we are going to decrease the coupling level of one system with some third-party dependencies, and we want to introduce a library to kind of wrap those third-party libraries or utilities so that for our system we only see a unified interface or API. And in order to design a better for use API, I used some techniques in this talk to make it more safe and easy to use, like that unchecked exception problem. Talking about optimization, generally speaking, we should write code in a simple way. And most of these suggestions or tips in this presentation don't apply to simplicity. So when you encounter a certain problem, think it twice if it's worth using any of them. Sometimes they can be useful, but not all of the times. In general, when to use different data types based on read or write operations, and making use the most of the object type for particular scenarios. So I translate your meaning to from this read and write operation to producer or consumer scenario. I don't know if I'm right, but if I'm right, I can tell that for producer, generally speaking, we should be strict as possible as we could. We should not give wild data. And for our consumer, we generally should be more generous. We should be more compatible, even if the data is invalid or has some errors in it or noise in it. And for types choice, for how to choose data types, I think it also depends on the actual situation. Maybe more abstract types is more generous, or more specific types is more strict, etc. So let's turn to another question. Do you think optional type can help to avoid non-pointer exceptions and make code more functional, or it's kind of syntax sugar and is not really necessary? Thank you for asking this question. Optional this type, yeah, I believe it's a tricky one. In my opinion, I don't use it very often, especially in the context of legacy system or a system that is not mandatorily required to use optional to get rid of non-pointer exceptions. In Java, we usually deal with non-pointer exceptions not necessarily by optional. This optional, maybe if you are interested, you can have a look at how it is designed, some discussions and papers about it, and also its other languages version of it. And in Java, I believe because of some native um, inertia or something like this in Java, programmers don't use it in a strict way. So I think optional, if you are going to use optional, you also need to think twice. Its usage scope is kind of limited, and if you use it arbitrarily, it can lead to verbosity or some other problem. But a proper usage is good. We've been facing issues related to containers when it comes to memory. Do we have any changes around containerization? I think this question belongs to another topic, right? The trick with uh, what exception in Lambda looks like a bug in Java? Are you sure it's not going to be removed in later versions? What's the idea behind this trick other than fooling compiler? I think we can. Thank you for asking this question. Yes, I kind of agree with you. This is a very good question. I think we can return to the initial purpose of checked exception. We have a OOP design principle called Liskov substitution principle, which requires us not to violate supertypes contracts when we do subtyping. So the designer of Java at the beginning, they want to put exception as a signature of this method. This is their effort. So we today have checked exception in Java. But in practice, most of us, we know that checked exception has limited value, and its drawbacks, like in this example, sometimes can be painful. As of why compiler is fooled by this generic casting, I have no idea. I didn't dive deep into it, but I think we can't say it's a bug. Maybe kind of compromising or something. We can say it's like this. So perhaps yes, it will be removed or kind of say fixed in future versions, but we can be sure. Okay, I think the time is up, and thank you guys very much. Thank you for your questions and for listening, for joining this presentation. Thank you very much.